Good morning, guys. So, a reminder that I'll give you guys some extra time to finish your quizzes tomorrow because tomorrow's going to be a short lesson. However, today we're going to go ahead and start. So today's lesson is 8.3, basic trig functions. So go ahead and pull out your note packet. And your notes should look something like this, although they won't have a dark background. Can everybody see that all right? I know, it's very dark. Alright, so trigonometry, or upper level math for trig, deals with ratios in triangles. So the trigonometric ratio is a ratio of two sides of the triangle. And we have three functions for that we call sine, cosine, and tangent. And we'll shorten those to sine, S-I-N, cosine, C-O-S, and tangent, T-A-N. So when you see those abbreviations, you know that you're working with these functions. And these are the basic functions that we look at when we study trigonometry. So what we're going to look at today is just the basic foundation for these functions. And then later on, if you take trigonometry, pre-calculus, and calculus, you look at some more advanced concepts and ways that we use these. So the way that we set these up is, again, it's just a ratio or proportion of two sides of the triangle. So sine of one angle is the side opposite that angle over the hypotenuse. Cosine is the side adjacent to that angle over the hypotenuse. And then tangent is the side opposite that angle over the side adjacent to that angle. So if you look in this triangle, we're looking at angle A, as you can see, so the bottom right corner. So for sine, our side proportions are going to be BC over BA. For cosine, it's going to be CA over BA. And then for tangent, it's going to be BC over CA. So do you notice how the proportions are just a side over another side based on where we set up or choose the angle for that? So side opposite, side adjacent, and the hypotenuse. And we can do the same thing for the other angle as well. So if we were to use angle B, this is the adjacent side, this is the opposite side, and the hypotenuse is still the same. Now, we have a little shortcut that we use to help us remember how we set up these proportions. So go ahead and write this down in your notes. SOH, CAH, and TOA. We say that SOHCAHTOA, and it's an abbreviation to help us remember how we set up the proportions. So SOH, so, stands for sine, which is opposite over hypotenuse. So O for opposite and H for hypotenuse. So that's how we remember to set up that proportion. So sine, opposite, hypotenuse, or SOH. CAH, or is cosine, C, adjacent, A, and then hypotenuse, H. So we remember to set up the proportion for cosine as adjacent over hypotenuse by remembering that. And then our last path, TOA, T-O-A, is tangent, T, opposite, O, and then adjacent, A. So we use that to remember that for tangent, we set up the opposite side over the adjacent side. Does that make sense? So it's just a little shortcut to help you remember how to set up the proportions and which sides to use. So you can write that on the top of your homework, on the top of the quiz, on the top of the test, to help you remember when setting up those proportions. Are there any questions on that? So if we were to give some variables for each side, for sine, we'd say, again, it's the opposite side over the hypotenuse. So in this case, it's going to be x over z. For cosine, it's going to be the adjacent side over the hypotenuse. So in this case, it's going to be y over z. And then for tangent, opposite over adjacent, so x over y. Are there any questions on how we set up the ratios? Okay, so part of the process is just asking you to set up the ratio. So on the homework and on the quizzes, it'll ask you to write the ratio. So here we're given triangle NML, and we're given sides 8, 17, and 15. And it wants you to find the sine, cosine, and tangent for angle L, and then the sine, cosine, and tangent for angle N. So all we do is just set up our ratios. So remember, sine is just the opposite of the angle, the opposite side of the angle over the hypotenuse. So in this case, for angle L, it's going to be 18 over 17. And then if you plug that into your calculator, you'll get some decimal. So most of the time it'll ask you to put it into decimal form and then round it up. We do the same thing for cosine as well. So it's adjacent over hypotenuse. So 15 over 17. And then again, plug that into your calculator and then round. And then we do the same thing for tangent as well. So we just set up the opposite side over the adjacent side, which in this case is just going to be 8 over 15. And then we do the same thing now for the other angle as well. So here, the sine for n now is going to be 15 over 17, opposite over hypotenuse. And the same thing for cosine and tangent of that angle as well. So for cosine, the adjacent side over the hypotenuse, so 8 over 17. And then the same thing for the tangent, so the opposite side over the adjacent side, or 15 over 8. Are there any questions on that?
So we just really got to remember just this sine, cosine, tangent.
So that's all the lesson is today, is just remembering how to set up the ratio and which ratio goes for which trig function. Are there any other questions? No?
We have to put it in decimal, or we can just keep it as...
Good question. So, no, you don't have to put it into decimal form, but your homework or the test or quiz may say, no, round to the nearest tenth or hundredths place. So if it does say that, then in that case you will want to put it into decimal. Good question. Kirsten?
Can you go back to the sine one?
Sure.
I know.
So if I'm going too fast with the slides, let me know, guys. That one?
The
other one?
L one.
Okay.
Sorry, I didn't get it.
No, you're fine. Like I said, if I'm going through the slides too fast, let me know. I want to make sure that you guys get everything copied down. So let me know whenever you're finished writing that down, and then I'll move on.
Okay, I got it.
Okay. So that's all we have to do, is just set up our proportions and solve. So same thing for this triangle. So it wants us to find the sine, cosine, and tangent for angle A, and then the sine, cosine, and tangent for angle B. So looking at angle A, what will we set up as the ratio proportion for that angle, for sine? Ambrose?
12 over 20.
So we're going to set the opposite side over the hypotenuse, because that's the ratio for sine. Remember, SOHCAHTOA. What about the cosine for angle A? What will we set up for that proportion or ratio?
Over 20.
So we'd set up the adjacent side over the hypotenuse. And then what about the tangent of A? Daniela?
12 or 20?
Well, close. So you're right on 12, but what will we set that over?
16.
So remember that tangent is the opposite side over the adjacent side. So notice that we use all three sides in each of our proportions, in each of our trig functions. So sine, we use the opposite side over the hypotenuse. Cosine, we use the adjacent side over the hypotenuse. And then tangent, we set the opposite side over the adjacent side. So notice that we set up a proportion for each side compared to the other side. You guys see that? So we do one side over the hypotenuse, the other side over the hypotenuse, and then the side over the other side. You guys see how we set up a proportion for each side to the other side? So you guys were right on that, and notice that they just simplified. And then the same thing, we do the exact same thing for angle B. We set up our ratio, and then we just put it in decimal form if it asks us to. Are there any questions on that? Okay, so we can also do the same thing, but in reverse. So let's say we're given an angle measure. So this angle measure is just going to correspond to a ratio. Now, for this, you guys are going to need calculators, and you're going to need a calculator that includes the trig functions on it. If you don't have a calculator with trig functions, you can buy a TI 30 calculator for like $10 at Walmart. That's pretty cheap, right? So any calculator that has your trig functions on it is all you really need for this. Now, a basic 4-function calculator isn't going to work for you, so you want to make sure that your calculator has buttons that say sine, cosine, and tangent on it. Now, their iPhone calculators, if you turn them sideways, remember also then bring up some more functions for you as well. So your iPhone calculators also have the trig functions in them. Just remember you have to flip your phone sideways to expand out the calculator as well. So that's also another option for you. So to solve for a problem like this, what we do is we follow these keystrokes. So you just hit the tangent button, the number 56, and enter. Now some calculators might do it differently, and they might want you to type in 56 first and then hit tangent, and it'll automatically calculate it for you. But this is the basic way that we're just going to input this into our calculator. And so if you plug your number in to your calculator, use the correct trig function, it'll give you some number, and that's just what your ratio is of your sides. So if you were given a triangle and you set up the ratio and then put that into your calculator and got a decimal, you'd get that decimal. So now we're just doing the opposite of that. So we're given the actual angle measure, and we can plug that into our calculator to solve for what the ratio of the sides are. Does that make sense? So this is just another part of the lesson. So we can also do the same thing for cosine and sine, and for any possible angle measure. So in this case, we have cosine of 90 degrees. So what we do again, we hit cosine, we type in 90, and then we hit the enter button. And you get 0. Now, up in pre-calculus, algebra 2, and some later upper level math, you'll actually learn and figure out why it is that cosine 90 equals 0, but you don't need to memorize that for now. You just need to be able to plug this into your calculator. Are there any questions on that? So again, we just do the same thing. So if we use a calculator to find the sine of 48, plug that into your calculator and then round it to the 10,000th place, and what would we get?
0.7431.
Now what about cosine of 85?
0.0871.
So are there any questions on that? All you have to do for this is just plug it into your calculator. That's pretty easy, right? So the next thing that we can look at is actually using these to solve some problems. So in this example, a fitness trainer sets the incline on a treadmill to 7 degrees. So that means that the treadmill is up 7 degrees. And it says that the walking surface is 5 feet long, so the rotating belt is 5 feet long. And it wants to know approximately how many inches did the trainer raise the end of the treadmill from the floor. So we can set up a triangle demonstrating this and put in the values that we know. So we know that the treadmill is raised up 7 degrees, and we know that the walking surface is 5 feet. So we can put in some variable for the side or the length that we're going to solve for. And then what we can do is do our conversion. So they give us feet, and they want our answer in inches. So we can convert 5 feet into inches. 5 feet, there are 12 inches in every foot, so 5 times 12 is 60. So 5 feet is just 60 inches, right? Then what we do is we just set up our proportion like we would. So notice that we're missing half of the proportion, but we do have the angle measure that correlates to. So what we can do is plug in that angle measure into our trig function, and then set it equal to the proportion, and then plug in the number that we know from the proportion. Is everybody with me on this step? So then what we do is we can multiply both sides by 60 so that we get our variable on one side by itself. And then from there, you can just plug this into your calculator. So all you do is, for most calculators, you just type in 60, then you hit sign, and then the angle measure, in this case 7, and then hit enter. It'll automatically know to follow and make that 60 times sign. Most calculators know to follow order of operations and set everything up itself. Some calculators might be a little bit different, so you might have to work with it and figure out how you set this up. So all you do is you just plug in the numbers that you know, get the variable by itself on one side, plug into your calculator, and solve. So in this case, if we plug everything in, we get 7.312, really long decimal. So the treadmill is about 7.3 inches high.
That's 6.6.
So if you got a different number, your calculator might have done something different, so you might just have to be careful about that.
So 60 in sign and times 7.
Not times 7.
Oh, that's perfect. What do you add?
So if it makes sense or works for you guys, go ahead and do your trig function first. So do sine of 7 first, and then after you get that answer, just multiply it by 60. So it's one extra step, but it can also help save and make sure that you're getting the correct answer. So we know how to set up the proportions, and we know how to solve if we're given an angle measure. So all we're doing here is we just use that angle measure and the proportion to solve for a side of the triangle. Does that make sense? Okay, so we can do the same thing here. So in this problem, the bottom of a handicap ramp is 15 feet from the entrance of a building. If the angle of the ramp is about 4.8 degrees, how high does the ramp rise off the ground to the nearest inch? So again, we can draw a triangle and then plug in what we know. So we know that the ramp is 15 feet away from the entrance. And we know that the ramp is raised about 4.8 degrees. And so it wants to know, in inches, what the height of the ramp is. So again, our first step, we're just going to convert 15 feet into inches. And then from there, we can plug that in and set up our ratio. So in this instance, notice that if we're looking at this angle, notice we're given the adjacent side, and we're looking for the opposite side. So what we do is use tangent, because we know that's the ratio that we use for tangent. So you'd set up your problem as the tangent of 4.8 degrees equals your variable, whichever variable you choose for that side, over your 15 feet after you've converted it to inches. Then you multiply both sides so that you get your variable on one side by itself, and then you plug those numbers into your calculator and solve. Are there any questions on that? So today's lesson is just this trig functions. That's all we have to do. So some of the problems might ask you to just set up a ratio of the sides. So it might say, set up the ratio for sine of this angle, or set up the ratio for cosine of this angle, or set up the ratio for tangent of this angle. It might ask you to plug the numbers into your calculator. So it might give you an angle measure and ask you what the sine, cosine, or tangent of that angle measure is. So you just plug that into your calculator and get some number and then round it to whatever place it might ask you to round it to. Or you could have some story problems like this where it gives you an angle measure on one side, so you have to set up your trig function with that angle measure and then set up the ratio of the side and then just solve for the missing side line. Are there any questions on that?
Do you show like the
Sure.
proportion?
There we go. So what we do is we'd set up the tangent of 4.8 degrees, and we set that equal to the ratio. So we're looking for this side here. So I'm going to go ahead and put x as my variable for that side. And remember that tangent is opposite over adjacent. And then 15 feet we convert to inches, so we multiply 15 times 12. Multiply so we get 180 inches for 15 feet, excuse me. Then from there what we do is we multiply both sides by 180 so we can get the variable by itself on one side. So what we'd end up with is 180 times the tangent of 4.8 degrees equals x. And then just plug that into your calculator to solve for x. So plug that in and you should get that it's about 15 inches. So it'll probably come out to 15 point some really long decimal, or 14 point some really long decimal that you just rounded up to 15. Does that make sense? Are there any other questions on this example? So that's all you have to do. You just pick the correct trig function, put in your angle measure, set it equal to your correct ratio for that trig function, and then solve for the missing portion of your ratio. Are there any questions on that? Okay, so now you might be given an example like this. So now it'll ask you to solve for multiple sides of your triangle. It's the same idea like we did in the last example. So we're given an angle measure and we're given one side of the triangle. So we just use our trig functions to solve for the other two sides like we did with the last examples. So remember, sine is just the opposite over the hypotenuse. Cosine is the adjacent side over the hypotenuse. So we set up our trig function with our angle measure, and we set that equal to the ratio, and we plug in what numbers we know. Same thing with cosine. We multiply both sides, so that way we can get our variables by themselves. And then we just plug those into the calculator to get our answer. So now, rather than having a story problem, all it's asking you to do is find the other sides of the triangle. Are there any questions on that? So this is just the very basic foundation for trigonometry. And like I said, in upper level math, you'll learn how to take this even further. Can I move on? And again, again here, we do the same thing for this triangle as well. So we're given an angle measure, we're given a side, and I want us to find the other two sides. So all we do is set up our trig functions and ratios. So remember, tangent is the opposite over adjacent, so opposite over the adjacent side. And cosine, again, is the adjacent side over the hypotenuse. So we take our trig function with the angle measure and set it equal to the correct ratio. We plug in the numbers that we know. Same thing with cosine. And then we multiply here to get our variable by itself on one side. And then we plug it into our calculator and solve. And then we do the same thing for cosine. But notice that our variable is in the denominator, so what will happen is we'll multiply both sides by our variable, and then we'll divide by our trig function to get our variable by itself. So that one's just adding an extra step. And then again, you just plug that into your calculator. So that's all there is to it. Nothing weird or fancy, just setting up ratios and plugging into your calculator. Are there any questions on that? Can I move on? Again, same thing for this triangle. So set up your trig function and ratio, get your variable by itself, plug into your calculator and solve. Same thing for the other side. Does anybody need me to work through this problem? Okay, so this is pretty easy, right? It's not too complicated. Can I move on? Okay, so that's not your actual homework. I have a worksheet for your homework. So, on the worksheet, it's front and back. All it is just problems like what we looked at. So, you'll be given a triangle, and it'll ask you to set up the ratios for each of the trig functions. You'll be given a story problem, and it'll ask you to solve. And then you'll be given some triangles, and it'll just ask you to find the missing sides using the trig functions. So that's all you have to do for this homework, is just exactly what we looked at. Are there any questions on that? All right, you guys have the rest of the period to work on this.